Hey everyone, this is Stuart King from the Planning Analytics team at IBM, and today I want to provide a bit of a quick demo of how to use Planning Analytics Engine on AWS to move data between different TM1 databases, between different models, using only Turbo Integrator processes. So what I'm about to show, it's not possible in the current on-premise variant of the offering. The functionality that I'm demoing is completely dependent on the new Planning Analytics Engine that's available in AWS and Cloud Pak for Data. Okay, so let's get started. So I'm going to go to Data and Models in Planning Analytics Workspace, and through Data and Models, I will create a new modeling workbench. You can see in my environment, I have two databases. The planning sample database, which is one of the common samples that a lot of people are probably familiar with if you've ever played around with the samples that IBM provides as part of Planning Analytics, and then a database called empty. If we look at the planning sample database, we can see it is just the planning sample database. If we examine the cubes, we can see that these cubes have data, in this case, numeric data. If we examine another cube here, this plan control cube, we'll see that it does have some string data as well, right? So it's a mix of numeric and string data in a couple different cubes here. The database called empty, it's not exactly empty. Because it does have some cubes, the same cubes as the planning sample database with the same dimensions and rules on these cubes. However, if we look at the views here, we can see that indeed this database is empty, right? There's actually no data, which is why I called it empty. The same thing for this plan control cube. If we examine this, we can see that there are no values in the string cells that exist in this cube, right? So basically two different databases with the same set of cubes. One has data, another one doesn't. What we're going to do now is we're going to actually run a process on this empty database or from this empty database, which is actually going to extract data from the planning sample database and pull it over immediately to load into the empty cubes in the empty database. Right. So in order to do this, we have a process that I've already created in the empty database called replicate data. And I'll quickly explain a bit about this process. So this leverages our new ExecuteHTTPRequest function from Planning Analytics Engine, which is really the equivalent of basically just a curl command line, if you're familiar with curl, being embedded in a Turbo Integrator process as a Turbo Integrator function, right? So this process does a couple different things, this replicate data process. The first thing it does is it handles authentication, right? So in my case, I'm using an API key to authenticate to the Planning Analytics SaaS on AWS environment. And then that authentication returns an access token, this bearer token, which is used to actually authenticate to one of my TM1 databases. The API key, it's generated outside of the product. There's a page on cloud.ibm.com that's used to generate the API key, even though the offering itself exists on AWS and it's run from AWS. In my case, this API key is already sort of embedded within the model as basically an attribute for my user. And of course, I'll show my user account in this empty model here, the model called empty. And here we can see, I've simply added a string attribute to act as my or as a place to hold my API key. And keep in mind, I'm going to change the API key after this video, just because anyone who watches this video might be able to pick out my API key and try and emulate me. So I'm going to go ahead and change it before I post the video, of course, just for security reasons. So here you can see I'm basically using the TM1 user function to get the current user that's running this process. I look up the API key from the element attributes clients dimension, the attribute that I just showed, and then I basically use that API key as part of a URL that I stitched together here with string concatenation within the Turbo Integrator process. At this point, I simply make the request to this URL, and this provides a response. It's actually a JSON response. So this section of code here actually has to do a little bit of string manipulation, basically to pull out the access token from the JSON response. So this code, of course, which I'll share as part of this demo and recording, shows you how to kind of parse out a single property from a JSON response. And then I store that as a variable called the bearer token. In my next request, I'm actually authenticating against the TM1 database here. And the URL that I'm stitching together this time is just the configuration endpoint. I'm just picking kind of a random endpoint in my TM1 database in order to actually hit that endpoint with my bearer token. just so I can get authentication or make authentication happen. And then at this point, I will get back a cookie from Planning Analytics SaaS on AWS, which will allow me to authenticate in subsequent API calls, right? So the trick here is that when we use ExecuteHTTPRequest and a cookie is returned for authentication or for whatever other reason, that cookie is reused on subsequent execute HTTP requests. It's also used if we access a data source, which is a remote data source on the same URL, which is what I'm going to do in a little bit later in this process. Right. So at this point, I've gotten a token. I've used that token to authenticate. I have my authentication cookie that allows me to make subsequent HTTP requests. So my next request, my next use of the execute HTTP request is actually to load a Turbo Integrator process that's sitting in this database called empty into the planning sample database, right? Now, where is the Turbo Integrator process sitting? It's not actually sitting as one of these processes here. Instead, it's sitting in the file area of the database. So if we examine the file area for the database called empty, we can see that we have a directory here called TI. And in here, we have a couple different JSON files, which basically store the Turbo Integrator code. The way I got these JSON files, very simply, I used a tool like Postman to make an API call to the database, basically to ask for the Turbo Integrator process. That returned a JSON response that showed me the Turbo Integrator process. I saved that as a file and then loaded it into this directory just with the upload feature through the file manager in the modeling workbench, right? So this code here, this execute HTTP request, it's a little bit different than the other ones, right? Because now it doesn't authenticate because I don't need to authenticate because I got the cookie, but it also grabs out of this TI directory that I was just showing the file, and then it loads that to the remote database. So this post call is actually taking the Turbo Integrator process that's sitting in the file in the empty database, and it's pushing it over to the planning sample database. And if I think I look here, we can see that the process already exists, right, in here. However, if I want to, I could simply delete this process. And when I run this code, we should be able to refresh the process list here and see it show up. Once this process is loaded into the remote database, into the planning sample database, I'm then going to call a bit of a worker process, where the worker process is going to be called once for each cube in the empty database, where the name of the cube simply starts with the prefix plan underscore, right? So for every plan underscore cube in this empty database, I'm going to run this Turbo Integrator process simply using the run process function. This should run a total of 1, 2, 3, 4, 5 different Turbo Integrator processes or instances of the Turbo Integrator process, where that Turbo Integrator process is the process that's actually going to do the work or the heavy lifting. That process, it's called extract and load data here. And once we examine this Turbo Integrator process, we'll see how it works. But before we do that, let's finish with the replicate data process. One quick thing here, this is a new Turbo Integrator function as well that only exists in Planning Analytics Engine. This wait for internal jobs is basically going to wait for all the instances of run process to complete. So this run process function is going to call 5 other Turbo Integrator processes, or the same Turbo Integrator process 5 different times. This worker process, right, which is this extract and data load. It calls it, of course, within this, this model called empty. This Turbo Integrator function, wait for internal jobs, it's simply going to wait until all 5 of these run process functions have finished. If I had 10 cubes, this would run 10 times, and this would wait till all 10 are finished, and so on. The last bit of code here is simply a bit of a cleanup code, right? So because I'm loading a process remotely into this planning sample database. Where is it? The planning sample database here. I'm going to want to clean up that Turbo Integrator process at the end afterwards. So I'm simply going to remove that process once I'm done with it in the planning sample database. And then because the Turbo Integrator process in this planning sample database is going to be used to export some files, I will want to clean up or remove those files at the end of this whole process, right? And of course, I have some parameters here to control that. I can set this to no for now, just to avoid running this kind of cleanup code in the epilogue, just so I can show the effect of how processes are loaded and what files get created within Planning Sample. Right? And we can take a quick look at the files in planning sample as well. Right now, you can see there's nothing in here that we wouldn't expect. There's no data exports that have happened that are kind of sitting around. Okay, so I mentioned run process here is going to run this extract and load data process 5 times. So if we examine this code, we can see it basically uses the same trick, right? It goes and grabs the API key. The API key from my attribute for my user is used in an API call to authenticate. Once the authentication here happens, I use that to basically get a cookie and then make subsequent API calls, right? Where the API call I'm making this time is actually going to be to execute the process that was loaded in the model, right? So I loaded in the previous process replicate data. I loaded a Turbo Integrator process into planning sample. Now this process is actually going to execute that process, right? That process, as it runs in planning sample, it's simply going to take the data that was loaded into in these cubes, and it's going to extract them to a file that's sitting on the planning sample database, right, in the file area of the planning sample database. Once I have that, and once I know what the name of that file is, what I'm going to do is I'm simply going to set the data source for this Turbo Integrator process, which is an ASCII data source. It's basically just a CSV file. I'm going to use that to kind of generate another URL here. And this URL is actually going to be the data source for this process, right? So it's going to pull data from a CSV file on the planning sample database into the empty database. And if we look at the rest of the code here, we can see it's really just a bit of a generic code in the data section, which is going to load the data from that CSV file into the corresponding cube within this empty database, right? And the reason this code looks a little bit funny is because it's been written to work with any number of dimensions, between 2 dimensions, and I think we can do a maximum of 16 dimensions, right? So this would work for a cube up to 16 dimensions. Of course, if I needed this to work on a cube with 17 dimensions, I'd just add another couple lines of code in here to support 17 dimensions, right? Because functions in TM1 like the cell put n and cell put s, they don't take an array. There's no such thing as an array in TM1. I have to kind of write this funky code, which looks a little bit interesting. It's just basically code that's kind of dependent on the number of dimensions within the cube that we're loading into, right? So not super complicated, but busy looking code. Okay, so let's go ahead and let's actually run this thing, right? And before we run it, we'll just go ahead and open up one of these views here. Actually, maybe we'll pick 2 of these views. We'll look at the smaller empty view with the string cells, right? And then we'll actually run this. So one other thing I guess I'll point out here, right? This does have some parameters. It can be configured. In this case, it's being told to work against all the cubes with plan _. I do provide this the name of the database that we're pulling data from, the URL for my AWS environment, an ID for the specific environment that I'm working in within my AWS instance, the name of the Turbo Integrator process that I'm remotely loading remotely into the planning sample database, and then these flags that determine if I'm going to clean anything up. So I'll go ahead, I'll run this, and we'll give this just a minute to run here. Right, so we can see, the process is running at this point. And once it's done running, what we'll do is we'll go and examine the views within the empty database just to see how data was loaded. Okay, and we can see it's run, it's complete, it's fairly quick, right? Just it's not an extremely large set of data. So I'll go ahead, I'll just refresh this view, and sure enough, we can see, our numeric data has been pulled for our cube with 7 dimensions. Our 2-dimensional cube with some string data, we'll refresh this as well and see that data has been loaded as well, right? So, it really is that simple. This process ran once, it called this process, replicate data, loaded a Turbo Integrator process into planning sample. This process execute and load data as per the name, it executed that process to extract data from planning sample to files, and then it used that file in planning sample as a data source to load data into the cubes in this empty model here, right? So if we examine planning sample at this point, we can pop open the file manager. We can see that, here's the directory that was created, this exports directory. And you can see for every cube with the plan underscore prefix, it basically made an export of the data in that cube, right? And you can see, some of these files are a little bit larger, some of them are a little bit smaller. If I wanted to download this and actually examine the data, I could and would see that it's simply just a CSV file sitting in this directory, right? But the trick here is that I'm using these CSV files sitting in the database, right? Because this file management area is contained within the database. These are accessible through an OData API call. Right? If I were to download this or delete it here, that's simply making OData API calls to this database, to the planning sample database, to retrieve the file or delete it. I'm just doing the same thing from the Turbo Integrator process in my empty database here. Right? So, data has been moved across, right? And the other thing I guess we'll show, right, is within this planning sample database, if we expand the list of processes, or I guess we have to refresh our list of processes here, we can see this export leaf data native process kind of showed up again. And if we want to examine the code to see what this does, we'd see it's nothing special. It's probably a piece of Turbo Integrator code that, most people have written once in their life, or probably 100 times in their life. But we can see that all this is doing is simply exporting the data. It's simply building a temporary view to export data from leaf level data from the cube, and then writing that data out. Again, it's been designed to work with any number of dimensions. In this case, I guess it supports up to a total of, I think, 12 dimensions here, right? As little as 2 and as much as 12. But if we needed to support cubes with more dimensions, I mean, we could add a couple else if statements in here as well, right? So this process, it's nothing special, right? All it's simply doing is kind of reading the data within these cubes, making sure it's leaf level data, and then simply exporting this data out to these CSV files, at which point these CSV files are read. One other thing I'll just point out quickly here as part of the test case package is I do have a cleanup process ready to go here. So we do have a process here called clear cubes. Very simply, this iterates over the list of cubes within this empty model, and it'll clear out these cubes using the good old cube clear data process here, right? So if we wanted to retest, make some other change, we could simply run this. It should run fairly quickly. Once it runs, if we refresh this and this, we should see that the data has been removed. And then we could try and run our process again, right? And if we wanted to prove this is live, we could do that very simply by maybe making a small data change here. Right, so I'll go 789, right? We'll punch in that value, and of course this is being punched in the planning sample model. You can see from the tooltip here. And then we'll run this replicate process again. Oh, here's my replicate data process here. This time we'll use our options to clean up. We'll try the cleanup options. We'll execute this one more time. We'll just give it a minute to complete. And once it does, we should see our live data change here, 789. While we're waiting, I mean, those of you who have been with TM1 for a while, this may look a little bit like the rep sync functionality. I would say it is, right? It's sort of the almost a modern day implementation of kind of rep sync, right? So there we can see it, our live change that was made in the planning sample model, 789, pulled from the remote queue. Okay, so that's it. That's our demo for the day, right? It shows us, how we can use a couple things here. The execute process function, ExecuteHTTPRequest, doing things like loading processes into remote databases, executing those processes. When I'm executing those processes, here's a bit of an example of how we set the parameters on the process that we're remotely executing, right? And then, once that process remotely executes, actually using that process or the output of that process, the file that was exported from the cube as the data source and reading this in, so we can kind of consume it in the model, that's running here. Okay, so with that, that's my demo. Again, this is Stuart King from the Planning Analytics team at IBM. Hopefully everyone enjoyed this. Leave your comments down below. And of course, I'll attach the file with this code sample. or make this otherwise publicly available with this with this empty model here, just as a backup in case you're actually using AWS or Cloud Pak for Data and want to try the same. All right, thank you very much.